All right, so in this video, we're going to solve quadratic equations using the square root method, okay? This method is going to be used in two specific instances. And in this example, you're going to notice that in the equations, we're going to have an x squared term and constant terms. You're not going to see an x to the first term, okay? So what we're going to do is we're going to isolate the x squared, okay, on one side, get the constants on the other, and then we're going to be able to take the square root of both sides, okay? So first thing here in example A, we want to add 15 to both sides. That's going to give me x squared equals 4, okay? Now algebraically, I want to get x by itself. In order to do that, I want to take the square root of both sides, okay? Whatever I do to the left side, I have to do to the right side, okay? So the square root of x squared equals the square root of 4, okay? Well, you might think, well, the answer is just 2. And 2 is one of the answers. But when we're solving square roots, a lot of our equations are going to have two solutions, okay? Either two real solutions or two imaginary or complex solutions. So when I take the square root of x squared, I get x. When I take the square root of 4, I have to understand that a positive 2 squared could be 4, but also that a negative 2 squared could be 4, okay? So I have to account for that and have both of those as solutions, okay? Check your work, plug 2 back in here, and plug negative 2 back in for x, and you'll see that both of these will be true in this equation, okay? In B, first thing we want to do is divide by 3, okay? So x squared equals 9. Take the square root of both sides, okay? And then x should equal plus or minus 3. So we've got two solutions again. A positive 3 will work here, and a negative 3, if I plug a negative 3 in here for x, that will work as well, okay? So pause the video here. Try to do these 4 problems, part C, part D, part E, and part F, okay? And then come back and check your work. All right, in C, I got to do a couple things before I get x squared by itself. So I'm going to add 20 to both sides, okay? I'm going to divide both sides by 3, and I get x squared equals 49, okay? Now I want to take the square root of both sides, and I get my two solutions, x equals a positive 7 or a negative 7, okay? Both those solutions will work if you plug it back in for x, all right? So in the first 3 examples, we've had 2 real solutions, all right? Now let's look at D here. If I've already got the x squared isolated, so there's nothing algebraically I have to do. So let's just take the square root of both sides, okay? I want to factor this negative 16 using perfect squares. So positive 16 is a perfect squared, and then times negative 1. And we just learned in the previous video that the square root of negative 1 is I, okay? So I'm going to have 2 imaginary or complex solutions here. So x is going to equal a positive 4i or a negative 4i. So plus or minus 4i, okay? Let's give E a try. If I subtract 4x squared and move it over here to the left side, I get 1x squared on the left side. On the right side, I subtract 20, so negative 16 minus that 20 is negative 36, okay? Take the square root of both sides, factor negative 36 using 36 and negative 1, and then we take the square root of those values. So x equals a plus or minus 6i, okay? And finally here, we're going to add 15 to both sides first. Okay, we're going to divide both sides by 3. Now we're going to take the square root of both sides. Okay, so I can't factor this using perfect squares, okay, but I can take out that negative 1. So my solution is going to be x equals plus or minus I, okay, square root of negative 1 is I, and then this 3 has to stay under the radical, so I radical 3, so plus or minus I radical 3. So that's how you use the square root method to solve quadratic equations.